Hello friends. Now in the second video vector we will discuss about what is a equilibrium. Okay. In general, equilibrium in vector means sum of the vector ai I equal to 1 to n acting on the system is 0. That means a number of vectors are acting at one point or a system. If they produce 0 resultant, then this is called equilibrium, means the system is equilibrium. Generally, word equilibrium is used for vector for force and torque. So in this case, vector means you take force, okay, linear property. Now in terms of symbol force, resultant force acting on the system is equal to 0. So this is your equilibrium. Okay. Now for example, if you take two vectors, number one, for two vectors, one is acting towards one direction, another is acting towards opposite direction. If they produce equilibrium, then sum of the two vectors must be equal to 0. That means you take any vector to one side, take the other to right. So this shows that the right vector having some minus sign means it cancels the first vector. The vector which cancels this vector, particularly this vector, is called equilibriant. This vector is called equilibriant. Usually equilibriant is resultant of rest vectors whose magnitude is equal to that of resultant, direction is exactly opposite to that of resultant. So equilibriant always cancels the resultant of rest vectors. If you take three vectors, suppose one is F1 vector force, another is F2 and third one is F3, that is, as per equilibrium, sum of the three vectors is 0. You keep any two vectors to right and you take any one vector to left. So this shows that resultant of these two is cancelled by the third vector. Therefore F3 having some negative sign, it is called the equilibriant vector. Now in terms of triangle law, if F1 is a vector, F2 is another vector, sum of two vectors gives the resultant vector R in opposite order. But if you take minus F3, magnitude of F3 equal to R but direction is minus, means opposite, then F1, F2 and F3, they represents three sides of a triangle if same order. That means F3 is the third side whose magnitude is the same as that of R and direction is opposite to R. That means if R is opposite order, it represents the resultant of F1, F2. If F3 is in same order, for three vectors F1, F2 and F3, resultant is 0. That means in terms of triangle law or in terms of similarly polygon law, you can define the equilibrium. Okay. Now just example of Lemme's theorem. So what Lemme's theorem states, you take three vectors F1, F2 and F3. These three vectors are acting at a system in three different directions. If the system is rest, that means the resultant force acting on the system is 0. No resultant force act to it in the presence of the three forces, then the vector sum is 0. If this is the case, then what Lemme's theorem states that magnitude of one vector, you take f1 divided by sine of the angle between the other two, that equal to a constant quantity, and that constant is equal to again magnitude of the second vector divided by sine of the angle between other two. If you take f2, then angle between f1 and f3. Similarly, if you take f3, then this is sine beta. You can take this is. So now from this formula, that is, you can find out, you can solve the various situations of equilibrium, unknowns of equilibrium. Now in terms of triangle law, if you take f1 is along this direction, this is, and f2 is along this direction, f2, angle between f1 and f2 is beta, right? Then f3 is along this direction, angle between f2 and f3, this angle is theta, angle between, this is angle between f3 and f1, this is f3, angle between f3 and f1, this one is alpha. If you take triangles like this, these three represents three sides of a triangle in same order, then I can write this equation as f1 divided by sine 180 minus theta, this is f2 divided by sine 180 minus alpha, this is f3 divided by sine 180 minus beta. So we know that sine 180 minus theta is sine theta. If this is beta, you can write this angle is sine 180 minus beta. So f3 divided by its front angle. Similarly, this is sine 180 minus theta. This double line is sine 180 minus alpha. So you can take this angle also. This is nothing but exactly equal to, that is sine 180 minus theta. So you take whether theta or 180 minus theta, there is a sine, nothing is going to change. Okay. So this is your Lami's theorem, and it is purely based upon various equilibrium properties. Okay. Now let us start applications of equilibriums. I have given three figures. Three figures are there in the board. Let us solve one by one. Mark the point O is equilibrium point. It is neither moving towards right nor moving towards left. T1 and T2 are the forces acting in the strings as shown in the figure. In one string, the force is 5 Newton. Now angle between 5 Newton and horizontal line is 30 degree. Angle between T1 and horizontal line is 60 degree. So your duty is to find out to T1 and T2. Okay, T1 and T2. Now how can you find out? To find out, just you take, that is Lami's theorem. This angle is 60, means this angle you take, this is 60 plus 90, this is 150 degree. 150 degree. First you take known value. First you take known formula force, that is 5. This is F1 divided by sine 150. Sine 150, that equal to, you take T1 divided by, you take this angle, this is 30 plus 90, that is T1 divided by 30 plus 90 means sine 120 degree, that equal to T2 divided by, this is 60 plus 30, this total angle is 180 degree, 60 plus 30 is already 90, therefore this angle is 90, rest angles. So T2 is T2 divided by sine 90. Now if you compare, first 5 divided by sine 150 equal to T1 by sine 120. So find out the value of T1. Second, compare this again known value sine 150 to unknown value T2 divided by sine 90. then find out the value of T2. Okay, so in this way you can find out the values of T1 and T2. Now after solving you will get this is 5 root 3 Newton and this is 10 Newton. You solve and trial. Okay. Now let us come to the second figure. Come to the second figure. Now this point is a equilibrium point. You take this point is a equilibrium point. Draw a horizontal line that is parallel to the base upper line. Parallel to upper line, this is 37 degree, means this angle is 37 degree. This is 53, means this angle is 53. Okay. Now this point is a equilibrium point. Three vectors T1, T2, T3, they are in different directions. Okay. So now the weight is 100 Newton. This shows that T3 is 100 Newton. T3 is 100 Newton. Okay. So now you can take T3 divided by this angle. This angle, this is 37 plus 53. 37 plus 53 is 90. Therefore this angle is 90. First you take T3 by 90. That means T3 is 100. 100 divided by sine 90. You use triangle law. 100 divided by sine 90, that equal to T1. This angle is T1. Okay. T1 divided by this total angle 90 plus 53. Okay. 90 plus 53. This is sine. I am writing 90 plus 53. Okay. This is T1, that equal to T2 divided by sine. T2 divided by sine 90 plus 37. 90 plus 37. Okay. Now this is, you can adjust 100 divided by sine 90, that equal to T1 divided by sine. Mark 90 plus 53 means this is 180 minus 37, or this is T2 into sine 180 minus 53. Okay. So this shows that 100 divided by sine 90, this is T1 divided by sine 37, this is equal to T2 divided by sine 53. This is the value. If you compare these values, then you can find out the value. Put the values of 53 and 37 degree. I am writing here sine 53, that is 4 by 5, and sine 37 is 3 by 5. Okay. Sine 53. Sine 53, this is 4 by 5. Okay. This is sine 37, that is 3 by 5. These two are sine 90 is there, sine 91. Therefore, if you compare these two equations, find out to T1. If you compare, that is these two equations, find out T2. First equation, first value, second, compare, find out to T1. Second and first and third you can compare, find out T2, and after solving you will get T1 is 60 Newton and T2 is 80 Newton. T1 is, just I am checking the answer, okay, 60 Newton and T2 is 80 Newton. Already T3 is given beginning, that is it is 100 Newton. So with the help of Lami's theorem you can solve these problems. Okay. Now let us come to the third figure. Now in the third figure, angle is not given, but here this is the equilibrium position. An object is suspended in a string of length 0.3 meter. A horizontal force F pulls this object up to 0.10 meter. After 0.10 meter, the object is at rest. Mass of the object is mg. Suppose mass is given as 0.6, mass is 0.06 kg. You assume g is a acceleration due to gravity, that is 10 meter per second square. Okay, now how can you find out? So this is your angle theta. Okay, this is your angle theta. Now that is, this angle is 90, this is 90. Now this is your f. Okay, so now cos theta, from this you can take 0.10 divided by 0.30, this is 1 by 3. Then find out sin theta, this is root over 1 minus cos square theta, this is root over 1 minus 9, 9 minus 1, that is 8 by 9 root over. Sin theta is 8 by 9. Okay, sin theta is 8 by 9. Now you have to go to the log table to find out the values. Okay, so now therefore mg divided by, or f divided by, if this angle is theta, this is sine of 90 plus theta. F divided by sine 90 plus theta, that equal to mg. This is a known value. Mg divided by sine of, this is 90, means this angle is 90 minus theta plus this angle is 90. Okay, so this is 180 minus theta. Now sin 90 plus theta, this is cos theta, this is mg divided by sin 180 minus theta, this is sin theta. So not necessary to calculate sin theta, you can put the value of cos theta, put m, you put g equal to 10, then find out what is f. So f, its answer is 2.1 kgf. If you keep g, this is Newton, or this is 0.21 kgf. If you keep g, then the unit is in terms of kg force, and if you put g equal to 10, the unit is 2.1 Newton. So you can solve, I think not necessary to calculate sin theta. You can take sin 90 plus theta is cosine theta, that value you can put it and you can solve, and I think it will be easy. Okay, if you like this video, like it, subscribe it. Thank you.